All right, so next we have Dan Smith. He's a program manager for Extension's Nutrient Pest Management Program, and he will be discussing thirsty cover crops, termination timing, planting setup, and lessons learned from the 2023 crop season. Welcome to the program today, Dan.
Thanks, Josh. We might not get to all that, folks, today, but happy to send out my presentation to anyone that's interested in chatting more. I think where I want to start today is besides the fact that 2023 was really dry, that Steve did an outstanding job presenting on and telling us all the facts around that. It was tough in conservation systems. It was tough to see crops suffer because of those drought conditions. So there was just some inherent challenges to go into the field every day and seeing those challenges. At Lancaster, we saw 10 inches below normal rainfall. And there was a period of time where we received zero rainfall between May 6th and the 4th of July weekend. So that was really tough. So what we wanted to do was go out to the field and dig some plants because I was getting numerous calls and emails about this topic. And I said, you know what? Let's go out, let's dig some plants up, let's see where the soil moisture is. So the very first site that I visited was a full till site. And that was a site where I'm sorry, I'm going to close my office. The dog must also be on a Zoom call with some squirrels in the yard. So our very first corn plant that we dug up was in a full till system where the fall tillage had been done and then spring tillage had been done, really dried the soil out significantly. In that entire 6 to 8 inch root zone, there was zero soil moisture, really poor soil conditions. We moved into a no-till plot. Within 20 feet of this full till plot, it had been no-till for about 5 seasons now. We had really good root development, a little bit more soil moisture at about 4 inches. And then finally, we planted green. So we planted into standing rye that was 6 to 8 inches tall, then terminated that rye the day of planting. We had really good soil moisture at 2 to 4 inches. That rye residue is holding on to the soil moisture. And the below ground roots, of course, were doing a lot of work for that too. Unfortunately, the corn was really stunted. And that's why I was getting so many calls and emails and text messages was my corn looks really tough. Why does it look so tough in these rye systems? Did my rye take away all the soil moisture that I previously had? And it comes back to there's just many factors affecting these things agronomically. We're going to chat through a few of those today. So the take-home slide is go out and dig up some plants if you're ever stressed out about your crop, like we were this last season. Soybeans didn't care though. So soybeans at the end of the day really didn't care about the severe competition for moisture early on in the season. They did really well. We did see some potassium deficiencies occurring because of the lack of rainfall and thus nutrient availability in the soil. We did a lot of work last year where we looked at nitrogen rate in corn, and I thought that we were going to have to throw all this data away. I thought, in fact, most of our trials were going to be junk by the 4th of July. I was really discouraged by the entire process. But all in all, things worked out really to be okay in Southwest Wisconsin for the most part. There were some areas that were definitely challenged more than others. But these plots, we had zero nitrogen applied. You can see the difference between where we did not have that rye competition to where we planted green into the rye. The corn stand actually worked out just fine. We did get a yield off of that field. It's just a little bit tough to see all the corn plants that were in there. But that's kind of the things that we're spending a lot of time looking at. However, this was planted green and we sprayed it off the same day we planted. Where we did not spray the rye off the same day we planted, where we terminated 2 weeks later, as we were trying to work on in our trial, there was some severe yield penalty for that this year, some severe competition for moisture in that, say, May 15th through June 1st time period. And that's where the no-till plots really shined in that period of time where they did not have any residue to compete with at all. So we had some stand issues, contributed to planter setup, possibly, but all in all, the Lancaster team does an outstanding job of maintaining the equipment and setting it up for us to use. So I'm not going to blame the planter for the lack of seeds that germinated. I'm going to actually blame the soil moisture for that fact, in that we just hit some pockets of soil moisture where the crop germinated, and there was some places where it did not germinate because it didn't have soil moisture. And you can see that illustrated through these photos, those uneven growth stages. We saw this a lot of times when we had rylage harvested and then we planted corn into these fields where we had maybe V6, V7 corn next to V2, V3 corn. This was again from our plots in Arlington, very similar setup. where the corn just maybe didn't have any moisture to germinate. And there's actually some VE corn coming up here June like 23rd or so last year, and there's that potassium deficiency. For the sake of time, we'll keep things moving here. Remember that soil moisture, though, going into this growing season is only one piece of the puzzle. So if you don't have a really good plan laid out agronomically to manage low fertility fields, planter setup, soil structure, crop variety and hybrid selection, weed management, insects and diseases, all reduce yield. So that theoretical yield that we all hope for when we open the bag of seed and we plant into our wonderful spring conditions is all depleted by all these little factors. Moisture just one, and that's illustrated really well on the photo on the right. Was actually taken in a really wet year. From the road, you'd say, gosh, that's some really drought-stressed corn. It's because lamb's quarter is really efficient at taking up water away from the corn crop, shown there in the photo. We didn't control our weeds in this field. There was no drought conditions present. It was just simply a weed competition. So all these factors matter to really be optimized. So at the end of the day, to wrap up the non-data portion of my presentation, go out and dig some plants. I got to do this with Tony Pyrick this last year. We went out and visited some outstanding fields of corn in his area. He's a really early adopter of some innovative conservation practices, such as using cover crops and planting green. He had an outstanding corn crop. He had a lot of pieces line up for him, possibly a little bit different rainfall than what we saw in Southwest Wisconsin. But again, that's a very similar date to when I took those photos of those tilled fields with the very poor soil moisture conditions. And in Tony's fields, there was plenty of water holding capacity from those roots of the rye. So finally, to wrap things up, I've been lucky enough to be part of Dr. Rodrigo Worley's lab for the past 6 or so years, where we've been looking at this system study. And this system study is a really holistic approach where we have corn and soybeans in 2 different fields each year. And every year at Lancaster and Arlington, we're applying the same treatments to these plots. So essentially we have plots where we're doing full tillage, we're doing no-till, and then we have zero rye plots where we're having an early termination or about 2 weeks before planting, termination timing, we're planting and then terminating at planting timing. We have 2 weeks after planting termination timing, and we have a rylage harvest. Each one of these comparisons also has a no herbicide pre-applied plot versus a pre-herbicide applied plot. So we can compare the differences of a pre-applied herbicide. We skip through all the nuances of this trial. We're trying some of the more innovative ways of managing, say, nitrogen in this trial by side dressing and doing a spring pre-plant application with the planter for starter fertilizer. We're looking at rye variety changes as well, planting a rye variety that matures a little bit earlier than a non-selected variety would, that type of thing. Weather, we've already had a really good job of talking about weather. We have seen, this is the first time we've seen drought conditions though in the study. So we were very excited about that from a perspective of how do these treatments stand up amongst themselves. This shows rye biomass accumulation. Again, for the sake of time, I will send out these slides to anyone that wants them. Essentially, we're trying to hit 4,000 pounds of biomass as a weed scientist to suppress weeds. This chart shows that we rarely hit that. In fact, sometimes when we're terminating, say early season, we're getting 70 pounds per acre of biomass. So very low amounts of biomass are being accumulated. But in those plots that I showed pictures of that the corn was outcompeted by the rye, we had 5,600 pounds of rye biomass. So there's definitely a sweet spot for rye biomass and corn. We'll chat through that in a little bit. Just some photos showing 2022 versus 2023. We try and take photos at about the same growth stage at each year. I love taking photos of the crops to be able to show on days like today and to tell the story through photos. And you can see the difference between the pre and the no pre plots there with the weeds in the corn. The pre-emergent herbicide makes a big difference for yield at the end of the day because of those weed competitions. In corn, it's not such a severe penalty, but it's definitely a needed tool in the toolbox. And in the next slide, I'll show the soybean photos where the pre is essential. But you see the difference in corn dry down because we planted a little bit later last year to try and plant into some soil moisture conditions. And we got moisture later on in the season. So we got some rains that really saved us around the 4th of July and probably like mid-August or so. I know Doug Wiedenbeck's on the call. He could tell us exactly, but we got some really timely rains at Lancaster that really did save the crops and helped us produce a little bit more yield than what we anticipated. So you can see that delayed crop maturity in the corn. The soybeans, that wasn't as evident, but you can really see the weeds in the no pre-plots. We have a very healthy population of water hemp at the Lancaster site. These photos are from Arlington now, and a very healthy population of grasses at Arlington, along with some other broadleaves. So you can see where that makes a big difference. And the rainfall certainly did help activate those herbicides when we finally got it. So we did see some herbicides struggle to be activated last year. Talking about yields, where did we get hurt the worst? And this is my second to last slide. We saw pretty good yields, 238 bushels per acre at Arlington, in our plots where we had a pre-emergent herbicide and we were either conventional till, no-till, or early termination. Those are all statistically the same. So that means our early terminated rye, more soil health focused system yielded exactly the same as your tillage system, but you didn't have that very large tractor to pull your disc ripper with and your field finisher with, and all the added expenses of chisel plowing and then field finishing. You just had your no-till drill planting your rye. So there's definitely some big considerations, but you can see there where our rye did hurt our yields pretty severely last year. There was a competition effect. Soybeans really didn't care. That's been the story. As long as we're controlling our weeds, soybeans really just don't care about the rye competition. You can say, well, there's a little bit of difference in yield there, and yes, there is. We could spend more time talking about statistical difference, but today I think I should hand it over to Francisco. Our soybean yield overall, though, was pretty reduced because of the dry weather. 45 bushels per acre. We've gotten 70 and 80 bushel soybeans at Lancaster before in these plots. This is Arlington yield data, but again, significantly decreased from previous years. With that,
Dan, feel free to take more time if you need it. Don't worry about it.
Oh, no, with that, I can turn things back on over to you, Francisco, and take questions in the chat.
Great. Thank you. Thank you very much, Dan.